So in the previous video, we saw how objects in JavaScript are passed by references, and in this video, we are going to have a closer look on how this passing value by reference works. And in order to do so, we are going to use C++, which is a programming language known for allowing us developer to work more closely with the memory. And since passing value is something that is related to memory, we will use, of course, C++ in order to do that. And since this video will not really introduce anything new, but will try to explain how things works inside the computer, you can consider this video as optional, but I would argue that watching this video will give you a really solid understanding on what is going on when talking about references. So let's start by looking at this program and try to understand the syntax. It should not be so unfamiliar, but let's go through anyway. So this very first line is telling to the C++ program to import some code that has already been written, and in particular so that I can use this piece of code here, and we'll get to this in a second. And then we encounter an int main and some parentheses. Now, when we encounter some parentheses followed by some curly brackets, we know from JavaScript that we are talking about a function. And in particular, even if here there is not any function keyword, this is due to how C++ works. But I can tell you that this is a normal function that is automatically called when running a C++ program, and in particular when running a C++ program, the code that is run is what's inside this main function, and it is equivalent to declaring a function in JavaScript and then calling it, and this the code inside that function is called. So we know that when we see int main parentheses and a block of code, we are telling to C++, hey, look, I have some code, please execute this. So we know that the code that we are actually executing is what's inside here. So let's go through this. This unsigned int is equivalent in JavaScript to a let. So we are declaring a variable, and we can tell this since right after this unsigned int, we get a name, some equal, and then a value. So we are assigning a value to a variable. And in particular, in C++, we do have types, and we will explain types in one of the next videos. But for the moment, you are only interested in the fact that this is declaring a variable in C++. And then we get to this line of code, and we are using a std colon colon cout, and actually cout stands for console out. So we can imagine, and it is like so, that this is similar to console log, since out is the output of the console. So this is similar to calling console log, and actually this std here is just telling from where this code comes from, and in particular std means that it comes from the standard library, and this standard library is included by this io string. Then this is an operator that when used with something that can write an output, and of course console output is something that can write an output, and any kind of value will write that value into that output and then return that same output so that we can reuse it with another operator. So when doing this operation is just like taking this value and pushing it inside the console output, and then we have again a console output that we can reuse with some other values. And once again, doing this is taking this value and pushing it inside here, then pushing another value here, and so on. So of course, this line is very similar to this line in JavaScript. So now that we know what is going on inside this program, let's try to run it. And in order to run C++ program, we need to first compile it. And we can do that by doing G++, which is a program that is able to compile C++ program, followed by the name of the program we want to compile. And in this case is reference.cpp. And this will produce an out file. And this out file, if we go check it, we see that is colored in green, so we know that is some kind of executable file. And by accessing that file, we get the output of this C++ program. And in particular, we see that the output of this program is 2, which is the value that the a variable holds. And then this kind of string, we assume, since there are numbers, but there are also letters. And actually, this is not a string. This is a number in hexadecimal. And we can tell that this is, in fact, an hexadecimal number since it is preceded by the 0x, and then we get this. And this is actually a number. And we can actually take this number and putting it inside a calculator that is on programming mode, and you can select it by some option. And when in programming mode, you have to be sure that you can put inside some hexadecimal input. And if we paste here this number right here that we got, we see that even if this contains some letters, it is in fact a number and corresponds to this number. And in particular, it corresponds to this number here, that, as we can see, is a very large number. And what this number represents is just a slot inside the memory of our computer, and that slot is where that 2 is stored. So of course, our memory does have a lot of slots, so it's understandable that this number is so large. But what this is really just a number. So why am I telling you this? Well, in C++, we can of course create new variable from variable that already exist. And if we run this program, we see that we get, in fact, 2 as the value of A and 2 as the value of B, which has been created from A. But we also see that the number of the box that holds the A variable is different than the number of the box that holds the B variable. And that means that if I later change the B value, I'm only changing what's inside this particular box and not what's inside this box. The output instead will change if I create a new variable from one already existing, in this case, again, the A variable. And when creating this new variable, I put a commercial E here, and we were already using this commercial E in order to access the address of the box that held some particular variable. When using it when declaring a new variable, we are telling to copy the address of the variable and not the value of that variable. And we can see this in action. In fact, when creating the C variable from one already existing, the value is of course copied, but is not directly the value that is copied, but the box that holds that value. In fact, we can see that the C address is exactly the same of the A address right up here. We see that this number is exactly equal of this number. Instead, the number of the address of the B variable is different than the A and the C. So we know that here what we have copied is the box itself. And of course, by copying the box, we also copy what's inside that box. And we know for sure that since the box is the same, also its value is the same. And the difference here is that if we now modify what's inside that box, since the box is the same of the first one, we are also modifying what's inside the original box, since of course the box is the same. And by running the program, we see of course the same output as before, but when changing only the C, that, remember, as the same identical box of the variable from which it has been created, when modifying its value, we are modifying the value inside the box. And since also the original box will evaluate to that value, we are also changing what's inside the original box. And we see that the C and the A output are changed both, even if we only change the C, and the B output has not changed since it is in another different box. So here we are effectively passing a value by reference since they are referencing the same box. So I hope it's clear now that when we create an object from another object, what we are copying is the address of that box and not the value itself. And this makes sense since an object can be a very, very large object, and that would be expensive to copy it all. So instead of copying it, we are just telling, okay, look, this object already exists, just reference to that instead of creating an entirely new object as we are doing here, or here as an example. So if you learned something from this video, remember to like it and to subscribe to the channel so that you can keep learning with me. In any case, thank you for your time and we'll see you in another video. Bye bye.